again, who hasn't attended my first session. My name is Sebastian Daschner. I'm German. I'm a freelancer based in Munich, Germany, and well, a Java guy. I'm working as a Java consultant, trainer, and author. Mostly enterprise-related things, Java enterprise-related at most. Then I'm speaking on conferences like this, and I'm helping to shape the future of Java Enterprise in the so-called JCP, being part of several expert groups, and helping how Java Enterprise could evolve. And yeah, I'm also so-called Java champion, and so on and so forth. And this is my name in the normal written way, or this is the Cyrillic name. I hope it's correct. I can't read it, but yeah. And who of you likes live coding? Okay, then I have good news for you. These were almost all the slides. You have one last slide. This is this, more marketing about myself. So what I do, I offer consultancy and workshops for my clients on all kind of topics in enterprise-related things, enterprise application stuff, cloud-native technology with Kubernetes, Docker, everything you will see today, all kind of things. And the very last, I just recently wrote a book on architecting modern Java EE applications that already covers Java EE 8, that has just recently been out there. How Java EE, well, is fit for a modern world in cloud technology, in cloud-native containers, and so on and so forth. And now the good news, that's all with the slides. Slides are boring. Let's start with some content, right? So who of you has heard the term 12-factor applications? Hands up. Okay, a few. Who of you has heard cloud native, the term? Okay, also a few. Okay, just very briefly, these are kind of buzzwords and what that session is going to be about. So especially 12-factor app, it is an approach to, well, define 12 principles or 12 approaches how to build modern software as a service applications, modern web applications that are built for modern environments, basically how to build enterprise applications the right way. And there are a few principles, and I will gradually show you a few of them as part of this talk. And the other thing is cloud native. Cloud native basically means applications that are more or less born in cloud technology, or at least adapted, written for cloud technology. Whereas that not necessarily means cloud platform as in Amazon, it means more like the runtime, the environments, what we use. For example, the Cloud Native Computing Foundation is used to build, well, a foundation around all kind of containerized cloud-native technology. For example, Docker, Kubernetes, Prometheus, what I will show during this talk. And then I will show you two Java Enterprise applications that we built that cloud-native way. Why two? Because one is boring, and we want to have some communication. Right, so we have two applications that talk to each other, and we will add some configuration, some monitoring, and so on and so forth. And of course, run that in a containerized environment. So that's part of this this session. This session, I should also mention, that's smoothie session. So it's an introduction to this topic. And let's start with that. I have two applications that I prepared for you. One is called Hello Joker. So it's basically a Hello World application. And the second is called Joker Greetings. So it will calculate sophisticated greetings for us. And we will have these two Java Enterprise applications, built individually, deployed to Docker containers, and we will run this on a Kubernetes environment. Who of you knows Kubernetes and Docker? Hands up. Okay, quite a few. That's good. So we will show this, how to do that, and especially where Java EE shines in this. And yeah, let's just start from scratch. If you have any questions about that, just feel free to ask. But the idea is that I will live code everything for you. So basically what it is, this is a Maven project. I think you're quite familiar with Maven. The important story about that is it only contains the Java EE API, which is provided. That is quite important because that, it allows us to build zero dependency applications where we only include our business logic, our class files as deployment artifacts. Everything else will already be there in the runtime. This is therefore interesting because Docker uses so-called copy on write file systems that, leverage this principle where we can only ship a very thin layer, only our deployment artifact, and we don't have to copy megabytes of data around all the time, because Docker containers in total can get quite big, and therefore we can only ship our application all the time. And now what I'm doing, so this project, it's basically an empty Java 7 project. It only contains this mandatory Jax-Rs configuration. It doesn't even contain Java yet, so let's do this. To bootstrap the Jax-Rs process, Jax-Rs, for who doesn't know that, is the Java standard to write RESTful applications. So we have HTTP communication. This is what we're doing. We have an HTTP endpoint to the outside, and also the two applications will communicate via HTTP. And then we write a hello resource that, of course, says hello world to us, first of all, right? To start with something very simple and boring. Let's say hello, and of course we will use some, managed bean, since we are in a Java enterprise environment, right? Let's call this greetings. This will be, either an EJB or CDI managed bean, doesn't even matter. And of course we say hello then. Greetings, hello. So far and so easy, this just tells hello for us. From Russia with love, right? And that's basically it. Very boring, just a simple hello world application over HTTP. And now the interesting story begins. Now we want to, do a cloud native application out of that, right? Because for now, I have a command line here, hello Joker, and of course, we can build this via Maven, and then we have a WAR file, and so on and so forth. We could deploy this locally, but that's boring. Now we want to have a cloud native application, right? How we do that? Well, we want to containerize it. So this is, first of all, just a WAR file that could run on any application server, but now we want to run and ship that in a container. Because then we can take that container and push it, deploy it somewhere, and in our cloud platform, we can just run it, take that whole thing, have our specification, how the whole runtime looks like, that we can write in our project, just in a second, and run it there in the same way. So that means, what we need for that? Well, a so-called Docker file. What we want to do, we want to define in a Docker image everything that we need in order to run our application, right? So what we need, a Java EE application server, plus the Java runtime, and so on and so forth. So what we do, we write a Docker file, and actually I'm way too lazy for that, so I wrote several shell scripts that define, not much, basically this. We can choose any application server that is Java EE 7 compliant that we like, so I will use Tommy. It supports everything I'm doing here. And what we do, we just add our WAR file. This is our application I just built into, in this case, the auto deployment directory. So what we do, we're adding all these things to the Docker image, and once that starts up, it already has our application in there. That's a nice story about that, and that's it. That's everything we need in order to run our application. Because, everything is already contained in the base image. There is already Java installed, an application server installed, and we just add our WAR file, which is actually very thin. So as a matter of fact, we can see it's 4K in size, the hello joker.war. That's just our business logic, right? And now, what we can do, we Docker build something, right? Docker builds a new Docker image, and I will actually use localhost a Docker registry here because, later on I want to push it and pull it from Kubernetes environment, right? And we will call this, of course, hello Joker. Always be strict with version numbers. I will talk about this in a second. And build this into a Docker image. That's it. Copy the WAR file. That's super small, so it's very fast. It's built, and now we have our, environment. I could actually run this now locally, saying, please export this port and take this image, localhost, hello, Joker, version 1, and run it. There you go, and you run the Tommy in this case. And then you can actually call it from the command line, right, like curl, and then we have our hello, Joker. If I could spell resources hello, and it says from Russia with love, right? That's now a Docker container that runs locally, that has our application inside. But that's also boring, because, we want to have a cloud native environment, right? And this is just local installation of Docker. So what we want to do, we want to take this image and run it in a Kubernetes cluster. Why? Because then we get the whole orchestration for free. One application is simple, but later on we will see that we have several applications, how we can configure them in several environments, how they too can find each other and communicate with each other. That's the interesting thing, right? And that's also the thing where a lot of overhead has to be added, right? If we would do this manually, I can do this in Docker using manually. I can define networks and whatnot, and it's a lot of overhead. But I can also use an orchestration environment like Kubernetes and tells it, well, how to run our application, right? And this is also one of the first of the 12-factor principles, code base. So as I said, it comprises some principles for modern enterprise application environment. For example, it tells you you have to track your code base in version control. Well, thank you, Captain Obvious. This sounds obvious. But actually, if you read the text, it says, define everything you need in order to run your software under version control, including runtime, including JDK, and all the versions. And this is now what we're doing because we now specify in the Docker build, okay, I want Tommy in that version, I want the JDK in that version, and I test my application in this version, and then it will run. If I only ship the WAR file and you take a different application server than you do, then it could break, right? Because you didn't test it. So that's the point behind that, and this is also why we want to define everything here as code. And the Docker file does so. And now the same story holds true for Kubernetes. In Kubernetes, for example, in a container orchestration, what does it do? It will take the Docker image and run it in a more sophisticated environment. I have now more options to declare how my environment should look like. So now I specify this in YAML files. Who of you knows YAML files, the file format? Who of you likes YAML files? Oh, a few. Okay, at least. So I will specify just another directory, I call it deployment, and then I call this hello-joker.yaml. The reason why I don't find YAML that perfect is because it's like JSON, right? It's an object format, but if the indentation is important, like how many spaces you take to indent the thing, right? And this can get quite dangerous once you miscalculate the spaces and so on and so forth. So this is why I use an IntelliJ feature for live templates to define things like Kubernetes services. So this is how a YAML snippet looks like. What is a service? A service is a logical abstraction over a service. A service could be your application, that is a service. A service could be a proxy server. A service could be a database. So everything that is a real thing in your environment, everything that runs and, well, abstracts some kind of usable artifact in your environment. So that means our service, I will call it Hello Joker, comprises some functionality. In my case, the enterprise application. And a service is just, well, an empty thing. A service doesn't really contain anything. What actually contains our application, our running container, is a so-called pod. A pod is one or more containers. It's basically an abstraction around a container in Kubernetes. And these pods, we could directly create one, or we could create a so-called deployment. A deployment is even one abstraction level on top of that, and can say, I can have some pods here, and I can scale them up, so I can have several ones. You can already read replicas. Or I can take them and put them into a new version and manage these versions, and so on and so forth. I can have deployments then, and this manages a lot for us. Therefore, we use these deployments, so we don't have to specify them ourselves. And then, well, we take a so-called image. And now you can see, well, this is, of course, the image I just wrote, Hello Joker, version 1. And then define this for test cases, always. And then I can also have so-called probes. I will show this later on, what they do for us. Probes are basically a way to tell Kubernetes, is this application alive? Why? Because Java applications, and especially application servers, take a few seconds to start up. And if I would spawn the container and immediately direct traffic on it, then the application server might not be ready, right? And probes are a way to tell, are you ready? Are you ready? And then eventually we can direct traffic upon it. And we will have a liveness probe and a so-called readiness probe. Readiness probe. The difference is liveness tells us whether this container is alive. If it's not alive, then it's dead, we start a new one. And readiness tells us if it's ready to serve some traffic. That means if the application, in our case, is deployed. That means if Hello Joker resources hello is available, well, then our application obviously is there, right? So we use this as a probe. And then we can use so-called ingress. Ingress is like a outbound proxy, inbound proxy server. So we can say everything that comes to the path Hello Joker under this host, which I locally bind to my Kubernetes cluster, will go to our service. So that's basically a nicer way to use some kind of DNS, right? All right, let's start. What do I have here? I have an environment which is a Kubernetes cluster that runs locally on my laptop. Via Minikube, whatever. I have a cluster which is basically one node, so not really a cluster, but it doesn't matter. The abstraction can be used in the same way. So I can use Kubernetes in the same way, no matter if it's one laptop or the whole Google Cloud. And here I have a cluster that runs get pods, nothing. Get services, well, Kubernetes also nothing. That thing is empty right now. So what we do, similar to the Docker build, I take my description in the infrastructure as code, in my case the YAML file, and tell Kubernetes, here is it, go run. And then it will take the image that you saw, create a pod out of that specification, and say, so the deployment is the interesting thing here, and tell us, take this image, replicas 1, in that template, create one pod with that replica, and run it. So let's do this. The command for that is apply. So kubecontrol is the command line utility to access the Kubernetes cluster. And apply, well, applies a file, for example, this Hello Joker, and runs it. Apply, therefore, because we can reapply that several times, we can just take the same file, and if it's already existent, it will just reconfigure it. That's fine. So basically, it will tell us the service Hello Joker was created and deployment Hello Joker was created. And I just now forgot one thing. I forgot to push the image, right? So we already built the image. Yeah, here it is. We can rebuild it again. It will use the cache. It doesn't matter. But also we now have to push it, right? Because that has been built locally on the machine, on the Docker host, and now I have to push it to my Kubernetes cluster, basically. And then, okay, this already was started. I can actually now delete this on purpose. Why? Because that was the wrong one. And if I delete it, then you will see the deployment that's actually very eager. It will immediately see, oh, damn, you set one replica and there is not a replica. I immediately will start up one again. And this is actually a nice story about Kubernetes. I can show you that in the website. It was always meant to be production ready. So for those of you who doesn't know, Kubernetes originates from Google. It originally was the way, or still is the way, how Google runs their workload, and it was always meant to do this in a production-ready way. So it always is very resilient. It will start up new things for us, and now we will see, oh, great, we now have one pod, one container, basically, that is ready to serve some traffic. It's running since a minute, and nice, that's it. Okay, now we can access it, right? Curl in the same way. So what we can do, well, take the IP, no, actually take the DNS that I just configured, Kubernetes local, that is bound to the cluster, and then take this Hello Joker. You saw the ingress was defined to direct this into my service, Hello Joker, to port 8080, and now I can say, from Russia with love, hello world, from Kubernetes. With the probe already, this liveness probe that we will use later on. All right, so now let's do some communication, right? One system is boring, that's basically hello world. Let's have a separate second system that we will use for, well, do some calculation for us. Let's calculate some greetings. second system called Joker Greetings. Similar thing as before, it's an empty Java E7 project built via Maven, with only the Java E7 API being there. And let's also do, well, some REST communication, right? Let's call this greetings resource. So we will have a missing Java here. We have another resource. Let's say we call this, give us some greetings and calculate some greetings for us. Let's say we will post a name there and then we get some nice greeting. So let's say we want to create a new greeting that will output, let's say, some JSON. That will be nice, right? Post some JSON. Say calculate greeting from a name. So basically what we want to have, greetings and then slash some name. And then this is now Java Jax-Rs logic, Jax-Rs API. We can take this string that comes from the path and inject it via this method. So now the method handler, the Jax-Rs method, will take this part of the path and, well, we can use it. And of course, we will ask some managed bean again, greetings, to calculate something very sophisticated for us, right? Greetings there and return some greetings, calculate greeting from a name. And this will be, actually this will be a greeting which we now create with the very sophisticated business logic, hello name. Therefore we need a service for that, right? And I just saw that I cannot spell calculate. And then we return a JSON for that. Java E7 comes with a nice API, JSONP API. Nice short, I was part of that expert group, actually. And we can create a greeting that now comprises this greeting, right? Build it, and that's it. So basically, we can programmatically create JSON objects here. And Jax-Rs already knows, once we have a JSON object, well, I just output JSON. That can be done in a very thin way. That's nice for us. So basically, that's it, how we create a JSON with a nice greeting based upon the name. Yeah, easy and also boring. Now let's do something more interesting. Let's Dockerize this project as well. I told you already, I'm lazy. I'm too lazy to write 2 lines of code of this Docker file. So, Joker greetings. And I have a Tommy here again that now comprises my second application that can talk to the first. Same story as before. I can now Docker build this again, right? And also I will have some YAML description files, well, to control my Kubernetes cluster, right? To tell Joker greetings, to tell Kubernetes how to deploy this Joker greetings application. So now it will be quite similar to the first one. We again will have a service for the Joker greetings that's available on the port 8080. Yeah, that's nice. And of course, a deployment that will manage this for us. Joker greetings, version 1, let's say. We could do the probes now, but here it actually doesn't matter for the demo. And have an ingress here as well. That host. And everything under the path Joker greetings will now direct to this application, to that second service. And let's run this as well, right? So what we need, we first of all need a WAR file, right? Our application. Done. We have to have our Docker built. In the same way as before, now with the second image, Joker greetings 1, right? Let's build this again very fast. This WAR file is also very thin. And again, we will push this into our Docker registry. Also, it only pushes everything that not already exists, which is a very thin few kilobyte layer, so we are very fast. Again, leverage the Java EE principle, thin deployment artifacts. All right, and now let's do the same thing with Kubernetes here. Let's create services, deployments, and ingresses for the Joker greetings application. That means we will have, if I could spell, a second get pods, a second pod, and a second service to output the traffic for the greetings application. Same story as before, but now we will have a different service here. So we will call this Joker greetings, resources greetings, right? And here, of course, it does not work. We have to post something. If I could. And it will tell us, hello Duke. Actually, I just saw that the post, we could post something and post something as the method body, at the request body, but actually a post doesn't really make sense here, right? Let's change this to get. Agree? So either we post something which is part of the resource, and then we post the resource body, or we just say get something for that name. I think this is better. What do we have to do to redeploy this? Well, rebuild it, then Docker rebuild it to Joker greetings, right? And then push it, and then say, oh, nice story. We can actually either delete the pod. This is what I will do now. And in a second, I will show you a better approach how to do this using the Kubernetes way. Get pods, and now it will create a new container. And then it will run. And if I now get this Duke, then it will also return the JSON for hello Duke. If I say hello St. Petersburg, then it will also say this as well, right? Easy. Now, the interesting thing is how do we connect these two? That was two Hello World applications, not much better, but now we want to communicate. So basically what we want to add something for our first application that accesses our second application that runs within the same Kubernetes cluster. Because then it gets more interesting. So that means what we have, hello resource, let's create a second resource here as well that gets something for a specific path. For example, a name, right, which now uses the second system to calculate this. So the first one will be our gateway, if you want, that accesses the second one, which again returns a string, say hello for a specific name, just as before, well, similar, but now return a string, and now, of course, ask the greetings resource to, well, the greetings bean to output this as well. We will have a new method, and now it gets more interesting. We will add another bean. I will call this greeting, let's call it processor. And this is now our client that will access our second system. This is now the interesting stuff here. Let's say calculate. And you see the pattern I can't type. I always mistype this, calculate. What do we have to do here? We have to access HTTP, right? Our REST endpoint in the second system needs to be accessed here. What can we do? Jax-Rs or Java EE already comes with a nice HTTP client, namely Jax-Rs Client. Jax-Rs also has a client dependency, and we can instantiate this with a so-called client builder. New client, we will have a Jax-Rs Client here, and we can even configure this. If I say new client, and then property, configure HTTP, request time, HTTP connection timeout, and HTTP receive timeout. This is only necessary, let's say this is done in milliseconds, connection timeout 100 and 1000. This is only necessary because I use Java E7 here. In Java EE8, so this is what that is. It's CXF specific. Tommy uses CXF as Jax-Rs implementation, and therefore I need these properties. And well, if I would use Java E8 already, then this is not needed anymore. If you want to know about that, I show this in my book how this is done. But anyway, let's have a client here that is created, and now that client will be configured against a target. And now it becomes interesting. What do we write here? The target goes against our second system. We could write an IP, right? But that's a bad idea because we have to configure that IP everywhere. And once we go from staging to production, bad idea. We have to have a property. This is annoying. We could use some DNS resolvement and install a proxy server that gets reconfigured, or we just use Kubernetes. Because what we can do, and this is now the very nice story, we can use these service definitions as logical service names that will be replaced in a DNS-like mechanism from Kubernetes, using the service name and the port. That means we can easily write Joker greetings 8080, then we will be at that application. Why? Because Joker greetings will be resolved in the same environment and the same Kubernetes namespace to use that specific service. If we are in production, we will have a different environment, different namespace, different service, but the same code, because we only identify this via the logical service name plus the port. And this is now the nice story about that. We don't have to worry about the configuration anymore. We just use it, let Kubernetes do the lookup, and now we can connect these applications. Greetings with the target, and then, of course, we use the target with the subpath name and say request there will be some JSON, and please get this, and let's say there will be a JSON object, and then say the JSON object will have a greeting, which will we use. That's it. And of course, always important, close clients, close resources again. The predestroy annotated method is a nice way to tell, well, once the application server shuts down, it will close this automatically. Another nice story about Java EE. All right, anyway, this is now the code for deploying this into our second application. A lot of things can go wrong here, obviously, so there can be a lot of runtime exceptions. So what we can do, well, several things depend on our application, but ultimately we want to be fail-safe, right? We want to be resilient. The first thing is already done here, always define timeouts. Depending on your HTTP client, there are some client implementations that wait forever on a connection timeout. Bad idea, because that will block forever. No, we don't want that. We want to define timeouts, depending on your environment, of course. I will choose 1 second for receive and 100 milliseconds for connection timeout, whatever. We could also choose 200 milliseconds. Doesn't matter, just define timeouts. And then some, well, exception will happen there. And what we can do, well, similar things. For example, we can use an interceptor to say, once an exception happens there, let's do something sophisticated with it. Why an interceptor? Well, because we could reuse it at some point. That is just one idea we could use with Java EE functionality to, well, output something else. Let's say we define an annotation which will be an interceptor binding that says every failure will be null, right? With retention runtime, of course, the documented and intercept and binding. Then we can also specify our target will be a class and a method, right? Or a type and a method. That's just a simple interceptor binding. Anyway, that's just a glue code. We of course need an interceptor as well, so therefore we specify a failure to null interceptor. Null interceptor, which will be an interceptor that uses the binding failure to null. And if we don't want to use the XML something, we also define a priority to say this will be the application priority, so always load this, right? And then we can write an around invoke method. This is just the interceptor invocation context. This is just interceptor API to say once that failure to null, that intercept binding is specified, then we invoke this instead. And you can now do a lot of sophisticated things. So this is the default. Please always just proceed. That is just empty, right? But in our case, every exception that happens, this is now the very a very too simple way, but now please do something sophisticated with that exception. But for us, in that case, you can define some business logic here, output a proper value, but for us only output null, because then we will deal with null, and anything that can go wrong, we don't care, we just return null by defining this Java EE API. All right, and in order to see some changes, let's do something else from St. Petersburg with love, right? Let's do some changes here so we see some output, and then we can redeploy it, right? And now we changed our first application to access our second one. And now the interesting thing is, how do we deploy this? Let's say this runs in production already, and there will be somebody eagerly accessing this, or this, or this, or this all the time, and we don't want that somebody to fail, right? So what we can do, use Kubernetes features, use these production-grade ready features to say, we want to deploy a new version. So let's say we have a new version. What do we need to do? We need to build it. Build our Java application, done, right? This doesn't break anything, we just built the WAR file. Okay, now we can build a new Docker container, right? We want to have a new version, version 2, let's say, and we want to build this. All right, Docker build, localhost, hello Joker, version 2. Done, again, very fast because still thin deployment approach. Now we have a new version, hello Joker 2. How do we get the version 1 to version 2 now without any disruption? Well, I told you before, specify everything that comprises your environment here in infrastructure as code. So therefore, we define everything here. Oh, now it's not version 1, it's actually version 2. Now we change the version here, and we can tell Kubernetes to use that new version, please. So basically what we can do, we can use the same functionality again, say apply this new infrastructure as code, and now Kubernetes is intelligent and say, oh, this looks different, I have a new version here, so I have to redeploy it. Oh, and by the way, I will do it in a production-grade way, so I will not break anything. I will leave the old application intact until the new application is up and running and ready to serve some traffic. So basically, we can now deploy something here, and to make it more interesting, I can show you that this is still running, right? So let's have some while true, do ask this all the time, sleep, echo, done. It will now all the time ask our service whether it's still there, right? And also we can watch kube control get pods. We can watch our pods, what Kubernetes is doing there. So this is a Linux command. Every 2 seconds we will see what's happening. Anyway, now I issue this command. What happens? It tells us deployment. Now, arrow image pull. That's a nice thing. Did we push this? I think so, right? Oh, okay, maybe not. Let's push that again. But this is already a good feature because you see nothing broke. It saw, oh, I cannot pull this image for some reason. Let's leave the old one intact. Let's not kill it yet because it's not there yet, right? And wait a second, I think I built the wrong one. So just to be sure, I will rebuild it again. Hello Joker number 2, and I can basically, well, override it here. So let's do this so it doesn't pull the wrong one. And here it says hello Joker here, okay, and apply. That's great. And what we can do here, I can force and reapply it. So now it will hopefully try it again. If it doesn't try again, then, well, this is kind of hacky, but I can basically delete the part. So what it does, it delete part. It tries to be fail-safe, and if I cannot delete this part, then, well, it will start a new one. And now it worked. Hello Joker, the new one, and it's running. It's not ready yet, so it's still the old one. It waits until the Tommy internally in the Docker container starts up, and then ultimately it will be ready. It will be ready to serve some traffic, which we can see in this readiness probes that we defined, and now you see bad gateway. What was that? Nginx, yeah. Yeah, ignore that. Oh yeah, I know that. That's the ingress here. So normally that's the reason why this is not production ready. It uses Minikube that internally uses a VM that doesn't have, well, all the sophisticated feature. And the proxy that is used by ingress is not that fast to switch. So if I would use another URL, we can actually show this. So just that you saw the correct demo, the correct outcome. We can also, since this is a local environment, tell us, please access this. I have an IP. Because I only have one node, I have directly this IP that goes to that node, and I can also use another port, namely hello Joker, resources hello, which is the same thing. So now if I would, just that you see the nice outcome. Oh, echo sleep one, echo done. Oh, apparently I cannot write shell scripts. Do. For example, let's say I want to roll back for some reason. I don't like the new string. I want to reapply. Of course, this is also possible. Just reapply the old one of hello Joker, and then it will do the same story just backwards. And now, if we don't use that ingress with the local running environment, you will see that hopefully with a really zero downtime deployment. And then that uses then the old version. And then, of course, we can roll forward again, because ultimately we want to use the new version, right? Here you saw the immediate switch from Russia with love. And let's rewind this to version 2 again. And then we will use this. Oh, did I kill my environment now? That's interesting. Or I maybe misspelled the shell script. No, that looks good. Yeah. I don't know what that is doing. Maybe Kubernetes, the poor laptop, is crying because of such big amount of load, because it's still trying to terminate the old one. But anyway, when that is terminated, I will deploy the new one. If you do deployments, always wait until the deployment action is fully performed. Otherwise, you still have a running deployment action, and then you already have the new one, and at some point you will get problems there. Now it's done, and we can basically redeploy it again, rewind the whole thing. And once that is done, we will see again the new version that ultimately then connect to our second system. This is what we want, right? This now was just the, no, it's there, the new one. Then it will access the new second system. All right, so that was this demo. I can close this again. Curl, let's use the nicer ingress thing here again. Curl with that one, right? And now I can ask, give me curl for Duke. And now asking the first system, it will tell us hello Duke from the second system. Or, hello St. Petersburg. This is now the first system asking the second system. This is not a JSON response, this is the string response. And this is how we can connect them. And if we look again at the 12 factors, now we already, fulfilled a few of them. And I can explain the reasoning behind that. For example, second dependencies. Explicitly declare and isolate dependencies. What does it mean? We want to be specific on what we build and what we ship. So always define specific versions. Do not say, I want the latest of that image. No, I want version this and this, full stop. Because I tested that version running in my automated tests, and that version is running in production, and I know that this version works. If I update it just like this, I don't know whether this will work again. And this is also the reason why we always specify proper image tags, proper versions. Joker greetings version 1. Or in my Docker file, where is it? Tommy in this version, not just Tommy latest. I know that this version works because I tested that. This means always be explicit in these versions. Config, store config in the environment. Let's quickly do this. what about if we need to configure something, right? So you saw that we did not need to configure the host name because that's already part as a service. That is another of these 12 factors. We can, well, expose these services as logical service names, as resources that are exposed via ports. But let's say we want to configure something else, right? For example, we want to take this application and want to configure that greeting there. That comes, let's say, not hello, but we want to have a specific greeting. That is configured for each and every environment. So let's say this is a field greeting that now, unfortunately, Java EE doesn't come with a config standard yet, but what we can do, CDI. CDI is very powerful, so we can basically, well, invent our config, very thin config mechanism. Let's say we will inject something, and inject is, of course, a qualifier that is documented and retention runtime and so on and so forth, no runtime. And that qualifier now can specify, let's say, a string. A string, no, not this, a string value. And this value will be used to look up a config value, for example, coming from the environment. And I will quickly show you where this is going. So let's say this will be greeting.name. I mentioned CDI, so what we need to do, well, we need to expose that so it can be injected via this qualifier. What do we need to do? Some kind of configuration lookup mechanism, such as application scoped, such as a produces, take the right import method. Public string expose config. We can use this method to look up some configuration, for example, with a so-called injection point. So what that is, we can now get the injection point and ask this for our config value. That means this programmatically will go to our injection point, this is this one, and ask, okay, which value did you get here? Because we can access this and inject it by my method, and then look up, well, this value to somewhere. This is now the key to our configuration. And now the interesting thing is, how do we, that's boring. We can now go somewhere and take that configuration key and look it up. What we can do, we can now integrate that with Kubernetes, and let's say that comes somewhere from a file. Init config, let's say we have a properties, Java util properties, and now we will, well, do some file input stream, do some file input here. File input stream. Let's say we load this somewhere from, for example, opt-config or, app-config, something like this. And then we will have an application properties file or some properties file that will be used to file input stream to get our config values here. Let's say properties, load this from the input stream, and then init config, actually we don't have to do this. We can just throw this IO exception, and then we will load this from our Kubernetes environment. Load this here into this property file, and now let's return this from the properties file getProperty, right? Using this key. Basically, take a property file and load it, right? Easy. But now the interesting story is how we can do this in our Kubernetes environment. Because now I have a different configuration for production, for staging, for something else. And, well, I want to see how can I inject that into my application. Because what I do not want to build several different versions of my application. I want to build my Docker image only once, no matter where it runs, and take that specific Docker image, because this is the one I tested, and run it everywhere. And therefore, I have to, store config in the environment. I have to bring the config from outside, from somewhere. That means there is a nice Joker config. There is a nice mechanism that is called config map. It's basically a hash map that is stored in Kubernetes. And what we can do now, we can have multiple layer hash map and application properties. That is now the YAML key. And you will see in a second where that ends. And now we will have, what did I do here? Greeting name. Let's say hi, or hello world, whatever. This is just the contents of the properties file. This is the contents of this value. And this will now be injectable in a so-called volume. Let's say Joker config volume. We define a volume here. This is similar to Docker volumes, actually. That comes from a config map. The config map is called Joker config. And now this, can be mounted into the container. So we can mount this Joker config volume on a specific path, such as app config, right? If I get this right, yes, app config. And then we can map this as a file there. So everything that happens, everything that is here will be the contents of that file that will be mapped from Kubernetes. And now you can already get the idea. This file will reside then there, and on application startup, we load this whole thing, and then basically we inject that configuration, right? So let's build this. Maven clean package, build it into a WAR file. Again, and then Docker build this into Joker greetings version 2. And then push this into Joker greetings version 2. Done. And of course now redeploy it using this new version. Joker greetings, redeploy. All right, very good. You see config map created, so that config map is now there as well. And then the container will be created, and so on and so forth. And once that is done, now this is running the new one. That is nice. Also, what is quite nice, we can actually go directly into this and open a shell if bin bash, if we want to have a look what's there. So basically, we can see, look into the app config environment. Oh, there will be an application properties file, and it will now have this value. And it will have this value only on this Kubernetes environment. If we have a new new Kubernetes environment, we could change the contents of the config map and therefore configure our application. But anyway, we can now also directly ask the, again, second system, let's say with this, and it says, greetings St. Petersburg, not available. Yes, nice. Joker greetings. What did go wrong here? What we could do in this case, if something is wrong, it's still greetings. We could, for example, look into the log files here. It will tell us, exception. Of course, we did something wrong. Injection. So what is wrong here? That's the nice story about the live coding. Everything can go wrong at any time. That's good. So the more can go wrong, this will happen in production as well, right? And therefore, is not found. Greetings, property field. Okay, let's see. Oh, who knows what is wrong? I know it. I forgot to annotate this method, of course, with the qualifier. Otherwise, they don't know that the qualifier is somehow related. Of course, I can only inject it with a qualifier. Typical issue. Doesn't matter. Will happen to anybody. What we do, we rebuild and redeploy it, right? I already changed this from version 2 to version 3. This is normally why you have a continuous delivery environment, right? Build it from version 2 to version 3. Push it from version 2 to version 3, and apply everything here. And then you will see, same story as before, that it will run there. And then, ultimately, once that thing is, I did not specify a probe, but now it should be there. No, if not, then let's see it again. What's wrong there? Look into the log files. Oh, really? You know, live coding. This is what happens. Spy is not fine with qualifiers. Did I? Yes, I chose this. Okay, let's see. This produces the config here, and this will read the config there, so it cannot actually complain about this injection point. Did I rebuild it? I think so, right? Even clean package rebuilt everything here, and we are in the right project. Okay, just to be sure, let's do this again. Joker greetings. All right. Push it again. Just to be sure, delete the pod in this case. But I hope I got the story across, how this works, right? This is now the last attempt to do so. No, still not. Okay, then I'm not really sure why this is API types, greetings. Sorry, yes? The config? Oh. Oh, non-binding. Thank you. At least somebody's paying attention. Non-binding is the key. Yeah, you're totally right. Why non-binding? Otherwise, well, you can only add that binding. Yes, please give him a round of applause. Java EE expert there. That's very good. Oh, you don't want to see that? Okay, maybe not. And once that is up and running, then we will hopefully see the new one. Greetings. Look into the log files. Yeah, this sounds better now. Server startup. All right. Awesome. Hi, St. Petersburg. Works with configuration. Now, if we would change that in a different environment, then we can change other things. All right, then very quickly, a few other things. Backing services, this is basically what we did by exposing the logical service name and the ports. Like you also see here, we only want to bind that via network ports. We only want to be dependent on this. Separate build and run stages, yeah, basically means use a CD server. What else do we have? Stateless processes. Docker, yes, these are Unix processes, and scale out via the process model. Basically, if you want to scale out, let's do this. In this case, fire up new instances. 2. Let's say we want to have more Hello Joker applications. Done. We create it. If we say, give me the deployment, then we will see, oh, now desired 2. Okay, we will start up 2. And once that is up and running, we will have 2 applications that will be load balanced. Easy. More easy than asking the ops guys to install another server, right? Now it's up and running. Done. And yeah, a few other things, especially logs are important to not log too much or to not log at all, but that's a very different kind of story. So that's all we can do in this given time. I hope you saw the idea what we can do with cloud-native technology and especially how Java EE shines with, well, the API that we have and with thin deployment artifacts. If that was a little bit too short for you, I can tell you I explain all of this deeply and with well, functioning demos in my book, Architecting Modern Java EE Applications. Beside that, we will have a discussion around outside. So if you have any questions regarding Kubernetes or especially the integration with Java Enterprise, I welcome you to join us there. And Besides that, spasibo, and thank you very much for your attention.